Let's start. Last time I talked to you about this. We're going to start with a new chapter. It's applications, but it won't take too long. I think we should be able to cover it within today's class. We've already seen a couple of applications. Last time's sessions, some of you had presented in class. We saw some application. There are some there are many applications. Actually, I'll suggest you one video. Remind me at the end of the class. It's really nice. So it's on Fourier series, and it's very interesting. So even though you might not understand differentiation, calculus and all, you can still yeah, it's you see the video, remind me at the end of the class, I'll tell you about it. It's one of a very important application of trigonometry. Okay, so let's start with problems itself. As because we know trigonometry, we are going to use our knowledge of trigonometry to solve these problems. And then as and when we solve problems, we are going to see if any theory is there, we'll cover that. Okay, so the first question is this. Just read the question. Looks pretty simple, no? It's just told the story is very lengthy. Basically, you're trying to find the height of the tower, which is this. This is the tower and it's bent, right? So you're trying to find how tall this is, right? And you see that this is a right angle triangle, right? Because the shadow falling from here comes directly here. Okay, it's given that the sun is directly overhead. Only when the sun is directly overhead will the shadow fall straight down, right? This will be perpendicular to this. Okay, what else is given? You're given that this distance is 5.75 something, and you have this angle which is given to you, right? This angle is 5.5 degrees. So in terms of, you can tell in terms of sine, cosine, tan itself, you don't need to in terms of sine, cos, tan itself, you can give your answer. It's very straightforward. So this length is 5.75. This angle is given to be 5.5 degree. Stuti, you want to volunteer? How to solve this problem? You need to find this length, right? This is h. Yeah, I don't need the value. Don't worry about the value. I just need the expression. Sine of something, cos of something into something. Yes, Sai Pranav, how did you get that answer? Can you tell?
Sir, if you assume that if the tower was straight, it's tilting 5.5 degrees, so I subtracted 5.5 from 90 to get the inner angle, and then I did cos.
This angle will be how much? Inner angle?
84.5.
84.5 degree. Okay.
Yes, and then to find out the hypotenuse, I used cos 84.5. You need to divide 5.75 by cos 84.5, and you get the height, which is roughly 60 meters.
So cos 84.5 in this is adjacent by hypotenuse, which is BC by AC. which is BC is given by 5.75, AC is H. So from there, you can calculate the height to be
Yes, sir.
5.75 by cos of 84.5.
Yes, sir.
Okay. Whatever this is, you can put this on your calculator and you can find. Okay, but it's important that we get this. Right? Yeah. So basically, this line, whenever you're looking at, whenever you're making a measurement of angle, you will do it relative to some line, right? Relative to some ray, right? So that ray is called your line of sight. Okay. And this ray is basically parallel to the ground. Okay. So this is your ground. This ray is where your eye is at. Okay. And if you're looking at something above, it's called angle of elevation. Okay. Suppose a tower is here. Okay. This angle is called angle of elevation. If you are at the top of a tower and you're looking at something down, then this angle is called angle of depression. Okay, just some terminologies. Okay, let's try these questions. Surveyor in a helicopter is at an elevation 1000 meters. Measure the angles of depression to the far edge of an island as 24 degree and near edge as 31 degree. How wide is the island? So again, just try this question. There's a helicopter, someone is above ground, okay, and there is an island somewhere. And you're measuring some angles. So try to figure out what angles you're measuring. Uh, Pranav, can you tell me what are the heights? What are the angles here? What is this 24 degree and what is the 31 degree in this? Pranav Shane.
Um,
The person is here on the helicopter, right? This is the island.
yes, sir. Angle B is 31 degree and angle A is 24 degree.
OHB. This angle,
No, HAB.
this angle, HAB. What is given here? It's the angle of depression, right? So you are at a height, you are looking down, right? So
And then OHA will be 24 degree and OHB will be 31 degree.
and OHB will be, this whole thing will be 31 degree. Okay. So by alternate angles, you'll see that this is 24 degree, this is 31 degrees, right? And then what is given? Elevation of 1000 meters. So this height is given to be 1000. So can you continue, Pranav? How do we find this now? They've asked to find
Then
the length AB, right? Can we find any length here? One length is given, 1000 meters. These angles, you know, okay, from that, you know, these angles, right? Is there any length you can calculate, Pranav?
yes,
Which length can you calculate? Okay, Karthik is saying we can calculate BC. Can we calculate BC? Pranav?
yes, sir.
What about AC? Can we calculate AC?
Yes, sir.
Yes. How?
Then AC minus BC.
Right. So AB is nothing but AC minus BC. And how much is AC? How do you calculate AC? This length. This is the triangle.
Tan
Right?
of 24.
Yeah. Tan of 24 is 1000 by AC.
1000 by AC.
So AC will be tan 24 is 1000 upon AC. So AC will be 1000 upon tan 24. Right. Similarly, BC will be 1000 upon tan 31. Okay. Then you can put this in your calculator and whatever you find will be the answer. Right. Any doubts with this? Anyone? Okay. Next question. Angle of elevation of a top of a vertical pillar at a horizontal distance of 100 meters from its base. Incomplete vertical pillar at a is 45 degrees. If the angle of elevation of the top of the complete pillar from the same spot is to be 60 degrees, then how much height should be increased? So they're given this as 100 meters. They said horizontal distance of 100 meters from its base. So this is also 100 meters, but since this is 90 degree and this is 45 degree, this is 45 degree, this will be an isosceles triangle. Therefore, since this is 100, this also will be 100. Okay. Now you need to calculate x. Siri, can you tell me how you got this?
Sir, we can take tan 60.
Tan 60.
Tan 60 equal to BD by AB.
BD upon AB.
BD is 100 plus X. And AB is 100. So X plus 100 is tan 60 into 100. We take 100.
So x is equal to 100 root 3, which is 173 minus 100, which is 73.
Yes.
We approximated root 3 to 1.73. Okay. Fine. But so those were some simple introductory questions. So now, suppose there is some, if you are in a apartment or in your house, whatever, you'll have a terrace, and suppose there is a hill you can see. Okay, every place, Mangalore is slightly, hilly geography, right? So everywhere there are ups and downs. Usually, unless you're staying at the top, you can see some hill in your vicinity. Suppose you want to calculate the height of this hill, right? One, always till now we have seen that if there is a mountain here, if we walk till the base, we can, if we know this length and we know this angle, we can calculate the height, right? So, but if you look at a hill, there are some problems with that, right? What are the practical problems with that? If you want to measure the height of a hill, what are the issues you might face?
The peak is not directly above the edge.
Right. The peak is not directly above the edge. Good. So that is one of the issue, right? Right. You can't, if you are, say, if you are somewhere here, you cannot go all the way down till here, right? This length you cannot calculate. Even though you may calculate this angle, you won't be able to calculate this length. And if you can't calculate at least one length, you cannot calculate the height, right? That is one of the issues. So to get around that, there is, we're going to do something else. Okay. So that thing, what we're going to do is this. So I want you to give some suggestions what we could possibly do so that we can calculate the height of, say, this particular mountain. Okay. So we'll take ground level itself. Okay. Suppose you're at on the top of your building also, if you're in an apartment, we can take this as the ground level, and to that we can add the height of the tower. Okay, that's not a big issue. Okay, height of the tower can be easily calculated. So let's just take this ground level. We want to calculate this height. Okay, height of this peak. Okay, can someone suggest what we could possibly do? Any measurements that we could do? One of the measurement that we clearly can do is if we stand at, say, this position A. Okay, one of the measurement that we can do is we can draw, let's say, this angle, and we can calculate this angle, right? Suppose this is some alpha 1. Now we know that we can't walk all the way till here. What else can we do to calculate this height? Any suggestions? Anyone? Can we find the hypotenuse? So this length, how can we find this length? You have to give me it's really like it's a tall place, so you can't like pull a rope or something and measure it later, right? It's something which is really tall. Okay, Karthik suggests we move a little bit and then we measure the angle. What will that give us? What will happen to the angle, Karthik, if we move a little bit?
Like it'll get steeper.
It might. So suppose I measure the angle from here, this will be quite steep, right? And if I move from farther, it will become flatter. This angle will change. Okay. Let's see. Let's see if we can see some other
Like
idea. Can we calculate the distance from A to the starting of the hill? Yes, this also can be calculated. This length also can be calculated. Whatever you need till this point can be done, but that also is a trouble, right? Like, the hill might be very far away. You have to walk all the way till there, and there are practical problems with measuring these things, right? Huge lengths. Okay, good. I'm glad you're giving your ideas. Yeah, Karthik, you can continue with what you are saying. So you're suggesting we move somewhere here, maybe, right? Is that what
Yeah.
you're suggesting? And then we measure this angle.
Yeah.
Okay, suppose this angle is some other angle, alpha 2. Then what do we do?
Then we can measure the length BA.
We can measure the length BA. Okay, suppose that is some length L. Okay, suppose you walk from if you're on top of your apartment, you walk from one corner of the terrace to other corner of the terrace. Okay, or if you're on the ground, you just walk from, say, some 10 meters or 20 meters or whatever. Okay, fine.
The height will remain the same. Like
The height will remain
the
same.
perpendicular height of the mountain.
So this height, let me draw this height. This height you're saying will remain the same for both the cases.
Yeah.
That is triangle C, for triangle COA as well as triangle COB, this height will remain the same. Okay. So
Then if we take the length from A to the edge of the mountain, say X.
from now we have named all sides. We don't need to take any X. Now we need to calculate OC, right? How do you do that?
Could we do it like the tan? We know the angle, so tan of alpha 1 equals to H divided by AO.
Tan of alpha 1 is equal to H divided by AO. Okay. Similarly, tan of alpha 2 will be H divided by OB.
AO plus L.
Yes, which is AO plus L. Okay. So to get, what do we need? We need H, right? How do we do that?
Yeah. Like we know the angle, so we can find tan alpha and tan alpha 2.
Right.
Then bring AO and AO plus L to the other side.
Yeah. So can I write AO as H times cot alpha 1 and BO as H times cot alpha 2? Yeah.
Yeah.
Now, how much is BO minus AO? If we subtract the two equations,
L.
which is equal to L. The left hand side is L, which is equal to H times cot of alpha 2 minus cot of alpha 1. So we find H to be L divided by cot of alpha 2 minus cot of alpha 1. Right? So practically, we have solved this problem of calculating the height of a place. Okay, we just move along some distance. Obviously, the angles will change. Okay, and if we just measure the angles accurately, L divided by cot alpha 2 minus cot alpha 1 will give you the height of this tower. Okay. Priyanka, you want to explain which part you will get? I didn't understand your second comment. We can take off the height of the hill which touches. So this part, are you saying? Till, but again, if you're calculating the angle, this won't be a right angle, no? So that will be an issue. Even if you know this length, this won't be a right angle. So you won't be able to calculate this length also. Yeah, Siddharth, you can calculate all the angles in ABC. That we'll get. But finally, your calculation will come to this. Okay. L by cot alpha 1 minus cot alpha 2.
Sir, I do not understand how you made both of them group together.
Which part?
How you group the angles together, sir? In the math at the bottom, the equations.
Here.
Yes.
Did you understand this line?
Yes, sir. Yes.
So now I took AO to this side, tan alpha to the bottom. Okay. So
Yes.
you get AO is equal to H upon tan alpha 1.
Yes, sir. So okay.
And 1 by tan alpha 1 I wrote as cot alpha 1. Similarly, BO is equal to H by tan alpha 2 H, which is H cot alpha 2. Then I subtracted equation 1 minus equation 2. Sorry, equation 2 minus equation 1. So LHS is BO minus AO.
Yes, sir.
Okay, which is L. BO is this length, AO is this length. So BO minus AO is AB, which is L.
Okay, sir.
Left hand side is L. Right hand side is H cot alpha 2 minus H cot alpha 1.
Oh, okay, sir. Okay. Okay, got it, sir. Thank you, sir.
This is direct application of that. Right? So H is equal to, we saw that L by cot of alpha 2 minus cot alpha 1. So this is L is 5000 in this case by cot of uh, cot of 12 degree minus cot 16 degree. So whatever you get will be the height. Angle of elevation of top of a tower from 3 collinear points ABC on a line leading to the foot of the tower are 30 degree, 45 degree, and 60 degree. When the ratio AB is to BC. Yes. The 3 points A, B, C. Tan 30 will be this height upon this height, right? I gave you a direct formula, no? For if you know this length, you can calculate the height, right? What was the formula? H is equal to L by cot alpha 1 minus cot alpha 2. Right. But now we don't see, we need to calculate AB is to BC, right? And for both the cases, we know this height is the same, right? And we know the relation between this height and this length, right? H is equal to L by cot alpha 1 minus cot alpha 2. So similarly, you can just bring this to this side. You'll get AB, which is L, is H times cot alpha 1 minus cot alpha 2. Similarly, BC will be same H times cot alpha this minus cot alpha this. Try. Let's see. That's a hint. Try. Okay, I've got a couple of answers. Sai Pranav, want to tell how you got your answer?
Yes, sir. I just used a formula, sir. I assumed height to be 100 just to have easy calculation, and then just applied the formula cot 30 minus cot 45 into 100, and then I ratioed that with to get the length between them, and then I ratioed that between
Hold on. First length AB. So length AB is equal to height times cot alpha 1 minus cot alpha 2. How much is that? Cot of this angle minus cot of this angle, right?
Yes, sir.
How much is cot of 30 degree?
Cot of 30 degree is root 3
And cot of 45 is?
minus 1. It's 1.
Okay. What about BC?
BC, it's 1 minus 1 by root 3.
1 minus 1 by root 3. So we want AB by BC, which is the ratio of these two.
Yes, sir.
Right. And H and H will anyway cancel. You don't need to take 100, no? These things will anyway cancel.
Yes.
Right. So you get root 3 minus 1 by 1 minus 1 by root 3. So if you take common denominator in the denominator, you'll get root 3 minus 1 by root 3, which is root 3 minus 1, root 3 minus 1 cancels out. You're left with just root 3.
Yes, sir.
So the answer is D. Root 3 is to 1. Okay. Hope you got it. Any confusion? Just use this formula directly. If you know the height, if you know this length and these angles, just directly use this formula. So no, it is root 3 is to 1 because AB by BC is root 3 by 1, not 1 by root 3. 1 by root 3 will be the opposite, BC by AB. Okay, just check. This is the calculation which goes. Might have done some error. Okay, let's try. Let's try 7th question. Private plane flies for 1.3 hours at 110 mile per hour. Bearing means just an angle of 40 degree. Then it turns and continues 1.5 hours at the same speed, but on a bearing of 130 degrees. How far is the plane from its starting point? So basically, with respect to some vertical line, okay, with respect to some line, first it moves at 40 degree, then it moves at 130 degree. This angle is 130 degree. First it moves like this, then it moves like this. So you need the distance from the starting point, right?
Sir, it's a bearing, sir. So wouldn't it be just an extension of that angle? It's not an it does not stop and turn. It's a bearing measurement. So it would just be an extension of that angle. So it would just go from 40 degrees to 130 degrees in the same direction.
In the same direction. How
Yes,
is
sir, because it's bearing, sir. It's not an angle change. It's in geography, bearing is the angle relative to the initial line itself.
Initial line, right? So
Yes,
this
sir.
is the initial line. So first the angle is 40 degree, right? So after the plane reaches this point, with respect to this line, it will be 130 degree. No?
Oh, okay, sir. Got it, sir.
So it will change.
Yes, sir.
Ashutosh, can you explain how you got the answer?
Yes, sir.
Yeah, tell me.
So, if you see the diagram, the angle between the two directions is 90 degree.
A, B, this line, okay, this is 130 degree. So you're saying these two are at right angles, is it?
Yes, sir.
This is 40 degree. So the remaining angle here in the straight angle is 180 minus 130, which is 50 degree. So 40 degree plus 50 degree is 90 degree. Good. Okay. So if it is 90 degree, then it looks like it's straightforward, no? So this first you need to calculate the length AB. So it flies for 1.3 hours at 110 miles per hour. So AB is equal to 110 into 1.3. Similarly, BC is equal to 110, same speed into 1.5 hours, right? So you have to calculate AC. So AC square is equal to AB square plus BC square, which is equal to 110 will be common. 1.3 square plus 1.5 square. Okay. Then whatever you get, take the square root of that. That will give you the answer. 1.3 square is 13 square 169 plus 1.5 square 225. How much is that? 4.94. So root of 4.94 is approximately 2.1. 2.1 is 441, right? Maybe 2.1, 2.2, somewhere around that. So 110 into 2.1, that is AC. So that will be your length. Any doubts with this, whatever we did here? Should I repeat any part? Anyone? Last part. Okay. So this angle is 40 degree. This angle is 50 degree. So this is a right angle triangle. So hope you understood this. This is a straight line. With respect to this, first the flight moves 40 degree. Then it moves 130 degree. Okay. So this angle is 90 degree. So we need this length and this length to calculate this length is. Right. So this length AB is this. First it moves 110 miles per hour at 1.3 hours. So distance is velocity into time, right? So AB is equal to 110 into 1.3. Then the second half, after turning, it moves for 1.5 hours with the same velocity. So 1.5 into 110. So AC square is equal to AB square plus BC square. Okay. So AB square is this whole square, BC square is this whole square. When you add the two, 110 square is common. So I've taken that out, 110 square. You're left with 1.3 square plus 1.5 square. Okay. So 1.3 square is 1.69. 13 square is 169. After the decimal, if there is only one, while squaring, you'll get 2 decimal places. So that's why it is 1.69. Similarly here, 1.5, after the decimal, there is 1 space. After you square, you'll get 2 spaces. So 15 square is 225. So 2 decimal spaces, which is 2.25. Okay. So add the 2, you'll get 4.94. Okay. So you'll get AC square is equal to 110 square into 4.94. So AC is square root of this, which is 110 into square root of 4.94. 21, 2.1, 21 square is 4.41. 22 square, I'm not very sure. 3.94, is it? Sorry. 3.94. Yeah. So if it's 3.94, then approximately 400, which is approximately what?
2,
2. So this is approximately 2.
20.
Okay. So AC is approximately 220 miles. Yes. The angle of elevation of a cliff from a point A is theta. After going up a distance k meters towards the top of the cliff at an angle alpha, it is found that the angle of elevation is a show that the height of is alpha. I think this should be alpha. Alpha. Show that the height of the cliff in meters is this. So you understand there's a cliff. Okay. Angle of elevation of this cliff from a point A. This angle is theta. Then after going up a distance of k meters towards the top at an angle phi. So what is happening here? What does the second sentence mean? After going up, can someone tell? At an angle alpha. Can you explain what this means? You're going up a distance k meters from A, but it is at an angle. Okay, you're not going straight. You're going now at an angle. Okay. So this angle is phi. This angle is phi. Okay, and you're moving for a distance k. So this length AB is equal to k. Now it is found that the angle of elevation is alpha. So from here, if you look, this angle of elevation is alpha. Okay. Slightly complicated, more angles. Maybe this, I can change the color. Angle is alpha. Show that the height of the cliff is something, some expression. Need to find the height of the cliff. So let me name all points C, D, E, F. That's it. Anyone wants to solve this with me? You can give your any initial comments. Anyone? Siri, anything? Any angles, any extra angles you can find, or any extra height, anything, or any extra constructions you want to make. Karthik, anything?
Thinking, sir.
Length AB is given. Some length we can find. So one of the length we can find. What length can we find? Since AB is given. If I drop a normal from here,
We can find DC.
we can find BC.
DC.
How can you find BC? BC is this length, no?
No, sir. DC. DC.
DC, this height.
Yeah.
This height we can find. Good. Because this height will be same as this height because these two lines are parallel. Okay. And this height, since we know this length, this height we can find. Good. So this part of the height is done. So BG is equal to DC, which is equal to BG is which ratio should we take, Karthik? Sine, right?
Sine.
Sine phi is BG upon AB. So BG is sine phi times AB, which is K. Okay. This height is done, which is this height. Other heights.
Sir,
Yes.
sir, angle DBE is equal to angle GAB. That is phi.
This angle is equal to this angle, which is equal to
So
phi.
we can find DE.
Hold on. So this length, these two are parallel. So these two angles are the same. So this angle also will be phi. Okay. Therefore, we can find what?
DE.
DE. How can we find DE? Similar triangles, is it?
Yes, sir. Similar.
Right. So this angle is 90 degree. This angle is 5, and therefore these two triangles are similar. Okay. So we have triangle EDB similar to triangle BGA. So what all lengths do we know? See here, we know BG and
BG and AB.
AB. So BG upon AB is equal to ED upon
BE.
BE, right? BG upon AB is equal to ED upon BE. So, oh, but we can't calculate, no, from that. EB also, we don't know EB. We need at least one length in this. We don't have any of the lengths.
Sir, but
Hmm.
sine of phi, they both will be equal
Sine phi will be equal.
in both the triangles.
Correct. So sine phi is this by
Ah,
this.
no, that will be the same thing.
Same thing, same ratio. We have not made use of this, no? Theta. Alpha also we have not made use of. Yeah, AG we can find, that's fine. So that AG we can find, this length we can find, but the problem is in this triangle, unless you know any one length, you won't be able to find the other length. So at least one length needs to be known, either this or this or this, to find the other length. Right? Because it's a ratio of sides, no? Okay. But this length we can find. Siddhartha, we can find this length AG. So are you saying you want to use this in some other way? Once you find this AG? AG is what is this cos, no? K by cos phi, this length. If we know this length, can we find this height? We know this angle. What else do we need to calculate to find this height now? Which angle? Ashutosh, any idea?
Sir, we can use the formula L by.
Correct. L by cos. this cot theta 1 minus cot of this angle, right? So this angle is this angle FGC. So if we can find this angle, then our job is done. Right? So the problem has boiled down to this. We find this angle, then this by cot of theta minus cot of this angle will give us the answer. So how do we find this angle? No, FGC. So there are many lines here, right? 3 lines followed by this angle. Can we calculate each of those angles? We need to find this angle, right? If we find that, we'll get this. So this angle is nothing but the remaining angle. How much is the remaining angle? This angle will be theta minus phi. What other angles do we know? This angle we can calculate. Okay. Seems like some angle chasing which we are not able to find, this angle.
Sir,
Yeah,
sir, that angle in the small triangle, I have not named it.
you can
The
name
BG and the other.
F
No, near the angle alpha.
here, this point.
Yes, yes.
What is this? GH.
H.
Okay.
So that will be No, no sir.
No. Okay, just Stuti saying FD is equal to FC minus DC, okay, which is H minus DC. Yeah, but we need to find H, no, Stuti? H is
Sir,
unknown.
sir.
Hmm.
Sir, angle BHG will be phi.
Angle BHG will be phi. This
Sir,
angle.
H is not that point, the above one. The dotted and the yellow, sir.
The dotted and the yellow line, this point.
Yes.
Okay. So that this we
That
take,
angle will be phi.
that angle will be phi because these two are vertically opposite, is it?
Yeah. And
Wait, this
GB,
angle, no? This angle won't be phi, no?
No, it's not 5.
Yes, sir. It will.
It will be phi. Why? Why is this angle phi? This angle won't be phi. This angle is phi. Something small we are missing somewhere. Think with the fresh, yeah, it's not clicking. Okay, I'll keep this pending. We'll try this in the next class. So some angle, basically we need to find this angle. So try and find this angle. Okay. Or if there's some other approach you can think of, we have managed to find this height. If we can somehow find this height, that will give us the answer. Right? Okay, I'll keep that pending. We'll try this later. Okay, let's go to the next difficult question. Length of a string between a kite and a point on the roof of a building 10-meter height is 180 meter. If the string makes an angle theta with the level ground such that tan theta is equal to 4/3, how high is the kite from the ground? So length of the string between the kite and a point on the roof of a building 10-meter high. So first you need a building. Building which is 10-meter high. String makes an angle theta with the level ground. So kite is somewhere here. Okay. It makes an angle theta with the level ground. This is the kite. Okay, let's assume that it's not very clear. Length between a kite and a point on the roof of a building is 180 meters. So all we can assume is this length between the kite and the roof of a building. This length is 180 meters. Tan theta is given. How high is the kite from the ground? So you need to find this height. Alpha is not a variable. Stuti. Alpha is a constant in the previous question. Okay, we are not varying alpha. First sentence is not very clear. So let's assume that this is what they mean. The length, the distance between the height, the kite and the roof of the building is 180 meters. Okay. So the string makes an angle theta. This angle is theta. Tan theta is given. You need to calculate this height. Looks easy. Please try this. Height h is also not variable in the previous question, Stuti. That is also a constant. This is a simpler question. Please try this. Let's name the points A, B, C, D, E. Karthik, want to try? Any first steps? Sorry? Yeah, Siddharth, it's fine. The first sentence is not very clear, so we assume that it is this and we can go ahead. So if we draw a horizontal line here, you see that this angle also will be theta. Let me name one more point, F. This height is 10. So H. Tan theta is 4/3. So we have to use this. So which is equal to the whole, yeah, let's take the whole height itself to be h. CD is equal to h. Okay, so which is equal to h by DE. What was the figure you drew, Siddhartha? Can you extend AC? Okay, extend AC to which point? think, did they mean this angle is theta? Downwards, okay. Is this angle theta?
Yeah, what if they mean like that?
Huh? Sorry.
It might mean like that.
Yeah, if this is theta, then it's straightforward, no? Yeah, sorry for that. I'm also seeing these questions for the first time, so I'm not very sure. So if we take this angle as theta, tan theta is equal to tan theta is 4, 3. Right. So if CD is equal to H, if tan theta is 4 by 3, we can draw this triangle. If this is 4, this is 3, this will be 5. Right. So this triangle is similar to this triangle. So we need this height. This length is given, which is opposite by hypotenuse, right? Opposite by hypotenuse here. So sine theta is 4 by 5, which is h minus 10 by 180. So h minus 10 is equal to 4 by 5 times 180. So how much is that? 36. So 36 into 4, 144 plus 10. So h is equal to 154 meters. Okay. Sorry, the English of this needs to change. If the angle of elevation of a cloud from a point above the lake is A, angle of depression is beta, this should be alpha. Angle of depression is beta. Prove that the height of the cloud is tan alpha minus tan beta by tan beta minus tan alpha. You want to see this solution? Sorry. Let me just show this solution quickly. So basically what we did here was the length of the string between the kite. Length of the string is 180 and this height of the roof is 10 meters above the ground and this length is 180. So this angle is theta. Okay, so you need to find this height of the kite from the ground. So since this angle is theta, you use this 3, 4, 5 triangle because it's given tan theta is 4 by 3. Tan theta is opposite by adjacent. Okay, so if this is 4, this is 3, this will be 5. And use that here. You need this length. This whole length is h. This is 10. So this is h minus 10. Is it done, Sushit? So also there is some mistake in this. Can you looking at this, can you tell, I'm guessing it's a mistake. Can you tell why the height cannot be this? Why cannot it be this? Why can it not be this? Using your physics knowledge. They're given that some angle of elevation is alpha, angle of reflection of the cloud is beta something. And
Alpha would be equal to beta.
alpha will be equal to beta if it is on the edge of the lake. From the ground level, if you see, maybe it will be this. But it seems that from a point some dash meters above the lake, right? So when you stand probably 2 meters above the lake, there's some angle alpha and some other angle beta on the reflection. This is you standing from the ground level. This angle alpha, this angle beta. First, my question is, why is this wrong? First of all, we can calculate the height, but my question is, why do you think this is wrong? Any guesses? Dimensional analysis. Have you learned dimensional analysis last year? Using dimensional analysis, can you guess why this is wrong?
This would be dimensionless.
Yeah, the length, it has to have dimensions of length, right? But there's no dimensions of length here. Right? So
Yes.
Yeah.
probably there is some factor, maybe some multiplied by x or something. So let's just take this point x meters above the lake. Okay, so you're standing here. Okay, there is some cloud here, and this is the lake. Okay, so the reflection of the cloud will be here, exactly here. Right. So this angle is alpha. This angle is beta. Okay, and this height is x. Now you need to calculate this height. Okay, so let's take this height as x. Okay. If this is y, A, B, C, D. Can you find any other length? Any other length? This height is the same as your height, right? This height, let me assume as y. Is there any other length you can find? How much will this length be? CD.
AC.
Huh? A,
AC.
B. A, B. Only this height. This height will be equal to this height.
AC.
AC. This height will be equal to this height.
Yeah.
Yeah, right. Because that is what reflection means, right? So
Yes, sir.
this height will be equal to this height. So this height CD will be x plus y. Okay, from here to here. What about this angle?
Beta.
Beta. Right? Because
Yeah.
yeah,
Corresponding angles.
corresponding angles, right? Now, what do we need to find? We need to find x is given. We need to find y, right? So the total height of the cloud will be x plus y, right? So x is given. We need to find y in terms of x. That is our aim. And in terms of alpha, beta, right? So can you do that? Is it? Do it. Try. You need a relation between alpha, beta, and y. And you need to get y is equal to something x times alpha, beta, y, something. Anyone? Any suggestions? Any lengths we can calculate in terms of x and y? What lengths can we calculate?
FB.
FB, correct. So FB is equal to which triangle you're taking?
Triangle FAB.
FAB. Okay, sorry. This triangle. Okay, so in this triangle, FB is equal to, what ratio will you take? Tan, right?
Yeah, tan.
Tan of alpha is equal to AB opposite by adjacent. So FB will be AB upon tan alpha,
Y by tan alpha.
which is Y by tan alpha. Okay, then is there any other way we can find the same length FB?
Then FB will be equal to 2x plus y by
Which triangle?
tan beta. The FB and the reflection of the cloud.
FBD, right? This triangle.
Oh yeah, D.
Triangle, if we take, we get tan beta is equal to BD upon FB. So again, FB will become BD, which is x plus y, which is 2x plus y divided by tan beta. Correct, Karthik?
Yeah.
Okay. Now what to do? Equate the two. FB is equal to this and FB is equal to this. Equate the two. So we get y by tan alpha is equal to 2x plus y by tan beta. Cross multiply. Tan beta times y is equal to 2x times tan alpha plus y times tan alpha, or y into tan beta minus tan alpha is equal to 2x times tan alpha, or y is equal to 2x times tan alpha by tan beta minus tan alpha. Right? And now our height of the cloud is x plus y. So to this y, we need to add x. Okay, so we'll get x plus 2x tan alpha by tan beta minus tan alpha. Okay, so you take common denominator, tan beta minus tan alpha. Numerator will be x times tan beta minus tan alpha plus 2x tan alpha. Does that give us the required answer?
Yeah, it will be x times tan beta plus tan alpha by tan beta minus tan alpha.
By tan beta minus tan alpha. Good. So this is this times x. Okay.